Welcome to the DIY Honda Garage channel. The DTC P26E5 indicates a low-voltage problem within the starter cut relay 2 control circuit in the 2022 Honda Civic. This error arises when the powertrain control module, PCM, detects that the return signal from starter cut relay 2 is low, while the starter is turned off. The function of the starter cut relay is critical, as it controls the starter motor's operation. Essentially, it prevents the starter motor from engaging when the vehicle is not ready to start. The circuit operates under a DC voltage. Thus, any voltage dips can disrupt performance and trigger this Diagnostic Trouble Code, DTC. The relay circuit board, which includes the starter cut relay 2 circuit, is usually located in the engine compartment, integrated with other control modules and electrical components. Understanding the nuances of this DTC is vital for effective troubleshooting and ensuring the reliability of the vehicle's starting system. The starter cut relay 2 plays a fundamental role in controlling the starter motor's activation process. Its primary function is to ensure that the starter does not engage unless specific criteria are met, to protect the engine and transmission from damage. This relay is located on the relay circuit board, situated within the engine bay. When the vehicle system is functioning normally, the PCM receives a high voltage signal from the starter cut relay during the off condition, indicating the relay is working correctly. However, if the PCM detects a low return signal from starter cut relay 2, it triggers DTC P26E5. This indicates data anomalies that could lead to operational failures. The failure of this relay or its associated circuits can prevent the vehicle from starting, essentially rendering it inoperable until resolved. Several underlying issues could potentially trigger DTC P26E5. A primary suspect could be a faulty starter cut relay, which may fail to switch correctly, resulting in an anomalous low-voltage signal. Additionally, damage in the relay circuit board can lead to signal interruptions or shorts due to environmental factors or wear and tear. The external circuits must also be inspected, particularly the IG1 starter cut circuit, which supplies power to the starter cut relay. Any breaks, shorts, or opens in these wiring paths can cause failures in the signal transmission. Lastly, if all else checks out normally, it could be the PCM itself that's malfunctioning, misinterpreting the signal, or communicating improperly with the relay. Thorough evaluations of all these components are essential to identify the exact cause of the error. When DTC P26E5 is present, several symptoms can manifest in the vehicle's operation. The most apparent sign is the inability to start the engine, as the starter cut relay 2 directly influences the starter motor's functionality. In addition, vehicle owners might notice that the starter motor either does not engage or behaves erratically, signaling potential electrical issues. Mechanics should also look for erratic voltage readings when inspecting relevant circuits, since this can often indicate resistance or poor connection issues. Finally, the presence of this DTC will be recorded in the PCM, alerting technicians and drivers alike that troubleshooting is necessary. Recognizing these symptoms early can help to prevent further damage and ensure timely repairs. To start troubleshooting DTC P26E5, ensure the vehicle is in the on mode. This is critical as the correct operational conditions must be established for any testing procedure. Next, inspect the relay circuit board's connections, particularly the IG1 starter cut circuit. This step checks for a proper 12-volt battery supply when the ignition is turned on. If the readings show abnormal voltage levels, this indicates a failure in the circuit that needs further inspection. Recognizing that a proper power supply is fundamental for the relay operation, culprits could be broken wires or poor connections affecting the signal. Early identification of these issues can steer further investigation effectively. The next troubleshooting step involves the disconnection of both the relay circuit board connector B and the PCM connector A. Making sure that both connectors are disconnected ensures that the circuits are not influenced by any external factors during your testing. With those disconnects in place, perform an open wire inspection on the ST-cut RLAY2 CL circuit. In ideal conditions, the resistance should read less than 1 ohm, which indicates that there are no breaks or shorts in the wiring. If the reading is higher than expected, this signals an open circuit or potentially damaged wiring, necessitating further investigation into the wiring harness. Diagnosing at this level is vital to ensuring the integrity of the signal pathways affecting the starter cut relay functionality. Continuing troubleshooting for DTC P26E5. Next, assess the same circuit for signs of being shorted to ground. This requires evaluating the ST-cut RLY2CL circuit while still disconnected. In this instance, the resistance should ideally measure more than 1 megaohm. A reading below this threshold suggests a possible short circuit may exist, which can cause significant operational issues in the starter cut relay's function. Inspecting for damage along the wire, such as abrasions or corrosion that may lead to grounding issues, is also important. Such shorts can cause unintended engagement or failures, affecting engine startup capabilities. With thorough inspections, technicians can help restore relay operations back to standard working conditions. The final troubleshooting step targets the PCM itself. If all prior inspections yield normal results, the PCM may be the root of the problem, as it orchestrates the commands to the relay and other components. Apply diagnostic tools to assess the PCM's condition, focusing on its ability to receive and send the appropriate signals. This step often requires sophisticated equipment to accurately validate the PCM's functionality. If the PCM is found to be faulty or outside operational parameters, it may need replacement. Alleviating a faulty PCM from the diagnostics is crucial, as it can introduce further complications if left unchecked, leading to chronic DTC trouble codes. After all necessary repairs have been conducted for DTC P26E5, the final step is critical for confirmation. Begin by clearing the DTC from the system to reset the vehicle's onboard diagnostic capabilities. Once cleared, recheck all system operations, especially focusing on the starter motor's functionality and the relay's engagement during starting attempts. It's vital to monitor for any resurface of DTC P26E5 after clearing. If it reappears, it signals the repair was ineffective, invoking the need for additional investigative efforts. This step ensures that the issues associated with the circuit have been fully addressed, allowing the vehicle to operate reliably without unexpected failures. To prevent the recurrence of DTC P26E5, implementing routine preventive maintenance is paramount. Regular inspections of the wiring associated with the starter cut relay 2 can detect wear or damage before they lead to significant failures. Similarly, consistent monitoring of relay performance can highlight early signs of failure, allowing timely replacement and reducing downtimes. A proactive stance ensures the integrity of the electrical systems remains intact, minimizing the likelihood of future voltage-related issues. Additionally, proactive replacement of aging components can bolster vehicle reliability, providing reassurance to the driver that the system will perform consistently. This foresight contributes not only to vehicle longevity, but also to driver safety. In conclusion, DTC P26E5 serves as a critical indicator of potential starting system failures related to the starter cut relay 2. Recognizing its significance in the engine's proper starting sequence, a thorough examination of all associated components is essential. Inspecting the relay, wiring, and PCM systematically addresses the root cause of the low voltage signal that triggers this code. Understanding these complexities allows technicians to mitigate risks for future occurrences effectively. Moreover, emphasizing preventive maintenance enhances the overall reliability of the Honda Civic, ensuring a smoother driving experience for the owner. Ultimately, addressing DTC P26E5 promptly can save time and resources, keeping the vehicle operating efficiently. Please like and subscribe to the channel. See you next time.